Hello everyone, I hope you are doing well. Today we are going to set up a really interesting project with Raspberry Pi and WebRTC technology. This web service is somehow same as AirDrop web service, and it enables you to have a peer-to-peer connection between your devices in the network in order to share files between them. If you're not familiar with Raspberry Pi or WebRTC technology, don't worry. We will implement it from the scratch, and I will give you some brief introduction of Raspberry Pi board and its usage, and also the WebRTC technology. Before we start, let me show you how the service works, and then we start to set up the project. The service is a website, and this website is served by Raspberry Pi, and you can share files between your devices. Every devices that is connected to the network can access to this website and open up the website. And for example, if a device wants to share a file, it just click on select a file, and let's say I'm gonna share this screenshot file. Then this file becomes shareable, but it doesn't upload on the server because, as I said earlier, this connection between your devices is going to be peer-to-peer. The file will send directly from one browser to the other browser. Okay, now let me and as you can see here, this link has also a QR code. I can scan this QR code with my phone. Let me just do it. And okay. Alright, as you can see here, I have access to this file, and if I click on the download button, this file will start to downloading. Let's see how it works. Raspberry Pi works as a web server in this project. It just serves the web service content, I mean HTML and JavaScript files. And every devices that have access to the Raspberry Pi in the network, they can just open up the browser and make a request to the Raspberry Pi IP address. Then they will see the web service web page, and they can share a file, as you have seen that. And after that, for every file, the web service generates a unique link, and then other devices can download that file through that link. They just need to make a request to that link, and then the transferring is done directly between the devices. I mean, for example, when the Firefox wants to download the file, a connection established between these devices directly, and Firefox downloads the file directly from these devices. It means the file won't be uploaded to the Raspberry Pi, and the connection will be peer-to-peer between devices. This peer-to-peer connection is done by WebRTC technology. And to initiate this connection, WebRTC has two main steps. I'm not going to get into the steps in more detail. The steps are signaling and transferring media. This picture is not totally right. The signaling process is done before transferring media between devices. And these two browsers for signaling, they communicate with another server called a stun or turn server. If you need more information about it, you can Google up about a stun and turn server. And in signaling process, they somehow exchange, let's say, the IP address, the public IP address of target devices, and after exchanging the public IP address, they're enabled to connect to each other directly. After connection, the transferring media will be started, and it's bidirectional. Usually these days, all of the streaming services, same as Google Meet or other streaming services that is based on browsers, they are using WebRTC technology. And this project can be useful, for example, in your home. You might have a lot of devices in your homes, like your smartphone, your computers, tablets, and sometimes you need share files between your devices as fast as possible. You might don't want to use flash disk or any wired connection. You might going to do it wirelessly. And you also don't want to use services like Google Drive or Dropbox because you need to upload the file at first on those services and then download it by the other devices, and it costs more in terms of times. But with this web service on the Raspberry Pi, you can have a peer-to-peer connection between your devices at your home. If you might also need this service in your company, because in your company there are a lot of user computers. Sometimes you need share files between the devices privately and very fast. That can be useful also for that scenario. Okay, what's on the agenda in this video? At first, we are going to set up the Raspberry Pi from the scratch. I will also give you a brief introduction of the Raspberry Pi and its capabilities. And then, as you have seen that, we have used FilePizza web service. Then we cloned the FilePizza web service on the Raspberry Pi. And FilePizza just works with HTTPS protocol. That's why we need an HTTPS certificate. Then we generate an HTTPS certificate on the Raspberry Pi. It's gonna be a self-signed HTTPS certificate. And finally, we run the web service on the Raspberry Pi. Raspberry Pi is a super amazing pocket-sized computer. It supports Linux. It has a lot of interfaces. For example, as you can see in this image, it has a lot of GPIOs. You can use these GPIOs in order to have a communication with sensors, with LEDs, and anything else. It has also 4 USB ports. It has network interfaces like Ethernet socket, and also Wi-Fi connection, Bluetooth connection. It has HDMI output. You can connect it to a monitor that supports HDMI. It has camera interface, audio output, and it's totally an amazing computer. It's really cheap. I think I've bought this board around $35, I think 2 years ago. And also it has different versions. For example, this Raspberry Pi is Raspberry Pi version 3, and recently, I think not recently, last year I think they also released the Raspberry Pi version 4 also. Okay, as I said that it supports Linux, we need to install a Linux machine on this memory SD card, and it's an ARM processor. You can set up different operating system on the Raspberry Pi, but officially the Raspberry Pi organization also have their own operating system. To download the operating system, you just need to Google up Raspberry Pi operating system. Okay, the first link refers to Raspberry Pi operating system, and the URL is raspberrypi.com/software. Okay, before we download the Raspberry Pi operating system, we need to an imager software in order to write the Raspberry Pi to the SD card. We can use different type of imager softwares, but this software, Raspberry Pi Imager, is recommended because it's implemented by the Raspberry Pi organization. It's more compatible with Raspberry Pi operating system and also the Raspberry Pi board, and it also has a lot of options in terms of installing different operating system and also apply setting like network connection, enabling SSH on the operating system, and etc. etc. Before downloading the operating system, I recommend you to download this software, Raspberry Pi Imager, for your operating system. It supports Windows, Mac, and Ubuntu. I've already downloaded it. I will show you. And after that, you need to install the Raspberry Pi operating system. There are 4 options, as you can see here: Raspberry Pi OS, Raspberry Pi OS 64, the legacy version, and the Raspberry Pi version for desktop computers. This version can be used for virtual machines. You can install this version on the VirtualBox or VMware in order to simulate the Raspberry Pi operating system. It's sometimes useful if you don't have Raspberry Pi board. You can download this version and install it on the virtual machines, and then implement your project at first in the virtual environment, and then finally you can deploy it in a real Raspberry Pi board. The recommended version is the first one. It has 3 types: Raspberry Pi operating system with desktop and recommender software, and the Raspberry Pi operating system version Lite. Each of them has different size. For example, it's around 900 megabytes. This one is around 3 gigabyte, and the latest one is around 400 megabyte. I'm gonna use this version because it's very light. It's gonna be downloaded very fast, and it doesn't have the desktop environment. When we install this operating system and after you boot up the Raspberry Pi, you just see a black terminal, and you can just write commands in order to communicate with the Raspberry Pi. Okay, we need to download this one also. I've already downloaded it. It's inside. It's here. Next step, you need to connect the SD card to your computer. I'm using this SD card reader. Let me connect SD card to my computer. Okay, and then we need to run Raspberry Pi Imager software. It has really simple user interface. Through this button, choose storage. You need to choose the SD card, and then you need to choose the operating system. It has different options. It is also able to download the operating system, but we have already downloaded it, and we should use this option. And then I choose the Raspberry Pi image. But before that, let's erase the SD card at first. Okay, it's done. And the next step, we need to install the Raspberry Pi operating system. We should use this option, use custom, and then we need to choose the operating system. And before click on the right button, click on the setting button. Okay, it needs my laptop password. Okay, we need to also enable the SSH on the Raspberry Pi operating system because we are going to connect to the Raspberry Pi with SSH protocol. And also we need to also set a password for Raspberry Pi operating system. I'm choosing Raspberry as password, and it's also automatically sets the default SSID that the laptop has connected to the Raspberry Pi. And when the Raspberry Pi boot up, it automatically connects this Wi-Fi, and it's get an IP address. Okay, it's enough. Let's save it, and then click on Write button. Okay, now we need to wait for writing. Okay, it's done, and now the SD card is ready to connect to the Raspberry Pi. Okay. Next step, you need to put the SD card into the Raspberry Pi SD card slot. At this point, something like that. And finally, you need to connect a power supply to the Raspberry Pi. The power supply should supply 5 voltage, and the voltage should be DC. Should be a DC voltage. Let's connect it. It has also 2 LEDs that shows the status of the computer. Okay, now it's booting up. Next step, we need to connect to the Raspberry Pi remotely through SSH protocol. You just need to open up the terminal, and then we need to connect to the Raspberry Pi. We have set the user to Pi on the Raspberry Pi, and the IP address. You can find the Raspberry Pi address from your Wi-Fi dashboard, or you can guess it with trial and error. Okay, and I've set the password as Raspberry. Now it's connected to the Raspberry Pi terminal. We can run command, for example, like ls or pwd. Let me clear the terminal. Okay, next step, we need to clone. Let's see if Git software is installed. Okay, it's not installed. You need to install the Git software. Sudo apt install git. You need to also install the Node.js, because FilePizza sudo apt install Node.js, because FilePizza is written in React.js, and we need Node.js, and also npm. For the next step, we will install npm. Okay, we need to run sudo apt update, and now we are able to install Node.js. Okay, it's done, and then this is the final dependency. We need to install npm.js also. All right, it's done, and now we are able to clone the FilePizza repository. You need to search about FilePizza, and this is their GitHub repository. Copy the repository link, and then we need to run git clone, and then paste the link. Okay, it's downloaded. Let's change the directory to FilePizza. Okay, now it's time to generate HTTPS certificate on the Raspberry Pi, because FilePizza just works with HTTPS protocol. Let's back to the slides. Okay, to generate HTTPS certificate, we need to run these commands, and they're not easy, and I never memorized these commands. And first we need to install the OpenSSL package. Let's do it. Sudo apt install OpenSSL. Sorry. Okay, it has installed, and then we need to run commands one by one. I'm gonna copy the first command. I will put all of the necessary commands in the description of the video, don't worry. Okay, that's it. I said that I never memorized this kind of commands because it's difficult to memorize all of them. Okay, it's done. Let's copy the next command. Okay, then it remove the server.pass.key. Pass.key. Okay, I've just removed it, and then run this command. Okay, it asked me some question. I just pressed enter. I don't care about this question. You can do the same thing. Okay, done. And the final command. Okay, it seems the certificates are generated successfully. Let's see. We have two files that refers to the certificates, server.crt and server.csr. Sorry, we should have another file, server.key. These three files refer to the HTTPS certificate, and we need to just pass this file, key, and CRT file to the web service in order to support the HTTPS protocol. To do that, to pass these two files, we need to set up two environment variables. Set HTTPS underline key, and then this variable should refer to this file. I'm going to use absolute address. The address is home, pi, FilePizza, and server.key. And the other environment variable would be HTTPS CRT, cert, absolute file path, FilePizza, and server CRT. Okay, there it is. Then we need to run npm install command in order to download and install all the dependencies, the FilePizza dependencies. It takes some time. We need to wait for it. Okay, it's done. Next step, we need to build a FilePizza web service, and then we need to run this command, npm run script build. Okay, it's built successfully, and the final command, we need to run the web service on the Raspberry Pi. Sorry, npm start, run start prod, and we are running it in production mode. You can also run this service through Docker, but Docker software is somehow really process intensive for the Raspberry Pi. Now I think it's ready to use, and the service is deployed on port 3000. To open up the browser and say HTTPS, then Raspberry Pi IP address and port number. For the first time, the browser shows us a kind of warning because the HTTPS certificate is the self-signed, and we can just bypass this warning. We can say okay, we accept the risk, and there it is. Now we have the file sharing service on the Raspberry Pi, and your devices in the network can access to the Raspberry Pi and use it in order to share the files directly between the devices, and it's really an amazing project. Thank you so much for watching us. See you later. Bye bye.